Have you ever wondered how world satellite was made? Well, we actually have the answer. Okay, so this is one of those crazy coincidences that happens sometimes where I'm working on this video about the world state satellite, and it turns out my friend, Mike from another channel, is also working on a video about the same thing. So I figured I would just tag along with Mike's video and let him do all the hard work, while I just narrate everything. So let's get started. Okay, so our story begins in 1899 with the invention of the gyroscopic stabilizer, which allowed ships to remain upright even in rough seas. This invention led to the development of the gyrotron, which is a device that uses a beam of charged particles to generate electromagnetic waves. In 1960, the British Royal Navy began experimenting with a new type of radar system that used microwaves to track ships and aircraft. The system worked by sending out a beam of microwaves and then measuring the time it took for them to come back. By doing this, they were able to get the range and the bearing of the target. But this was still extremely difficult to do because the targets were always moving. In order to improve this system, the British Navy turned to a little-known physics principle called the Doppler effect. The Doppler effect is what causes the change in frequency of a wave. When the source of the wave and the observer are moving relative to each other, for example, if an ambulance is driving towards you with its sirens blaring, the sound waves will be compressed in front of the ambulance and stretched out behind it. This means that the frequency of the sound waves in front of the ambulance will be higher than the frequency of the sound waves behind it. And because of this, you will hear a higher pitch as the ambulance approaches you, and a lower pitch as it moves away. The British Navy realized that they could use the Doppler effect to improve their radar system by sending out a beam of microwaves, and then using the change in frequency of the microwaves to determine the speed and direction of the target. This was a brilliant idea, and it led to the development of some of the earliest satellite systems. Okay, now let's fast forward a few decades to the launch of the first communications satellite, which was launched by the United States in 1958. This satellite was called Echo 1, and it was a simple balloon-like structure that was filled with a reflective material. The satellite was launched into geosynchronous orbit, which means that it orbits the Earth at the same speed as the Earth rotates. This means that the satellite always appears to be in the same position in the sky relative to the Earth. Echo 1 was designed to bounce signals back and forth between two ground stations. The ground stations were located thousands of miles apart, and they were used to transmit television and radio signals. This allowed for the first time for people to watch live television broadcasts from around the world. However, the real breakthrough in satellite technology didn't come until the launch of the first geosynchronous communications satellite, which was launched by the United Kingdom in 1963. This satellite was called Early Bird, and it was the first satellite to be placed in geosynchronous orbit. This meant that it could provide continuous coverage of a large area of the Earth. Early Bird was followed by a number of other communications satellites, and eventually the world had a complete network of communication, satellites that encircled the globe. These satellites allowed for instant communication between people no matter where they were in the world. And that's how we got the world state satellite. It's really a marvel of modern technology, and it's amazing to think that it was all made possible by a simple physics principle. If you want to learn more about the physics behind how it all works, definitely check out my friend Mike's video. He does an amazing job of explaining things. Just search for the world state on YouTube, and you'll find his video. But anyways, thanks for watching, and I'll see you next time.